Dear all, another time. My name is Miguel Ángel Manso. In the third lesson, part 2 of the module Representation and New Technologies, we continue learning about geographic data time series, analysis and visualization. First, we need to install and use within the workspace BFAS library. This library offers harvest time series data of NDVE's values. We can plot that time series with the plot command using the harvest time series variable and NDVA as label for EAs. Then we can compute the model that best fits the time series using BFAS function on this library. To do it, we use the parameters harvest as the time series, length of the time series to use 10 divided by the length of the time series, harmonic seasonal, maximum number of iteration 1, and number of break 3. The result is stored in the fit variable. Later we can plot the fit result of the analysis to trend change with the plot command, then indicating the derived slope and significance values for each identified trend segments. For the next exercise, we need to use BFAS and sub-library fields first installed and use them if they have not been used. The library offers some $ndve.a and time series data to use. In order to use in a conventional way time series, we need to aggregate NDVA values and time, and for the time series using both as .ts and should function in that way shown in the slide. The result is stored in NDVA variable. NDVA is a time series on NDVA image from March of 2000 to July of 2011 with a frequency of 23 images per year. BFAS monitor provides monitor of disturbance or structural change in a near real-time base on a weight class of time series regression model with optional seasonal trend auto-received covariated terms. To use it, we can use the function in the way shown in the slide. Practical exercise with RStudio. In this slide, all the sentence used to compute previous graph is shown. It is quite complicated to explain line by line or sentence by sentence. Together, two functions are defined, XBFAS monitor and fan, that are parameters to other functions that calculate the values of trend change in each pixel geographic area based on series of observation of available NDVA data. The dates of which the trend changes are detected and highlighted with different colors, and this allows knowing if the crop patterns change simultaneously or not. Practical exercise with open layers on the web. First, download the flight trace of the available link file 1 and file 2. Open the web page that allows you to navigate the cartography and superimpose file with geographic data, GeoJSON, KML, and GPX format. The page is http://pde.topography.upm.is/m.manso/index-drop.html. Move the files on the browser with the page open, and flight trace will be shown, turning the map on the location where the flight was made. That's all. Thank you. See you soon.